Please welcome to the stage Executive Chair and CEO, Gary Shapiro, and the President of the Consumer Technology Association, Kinsey Fabrizio.
Wow. You know, if I could walk out to this applause every morning, I don't think I'd be drinking much coffee. You know, you walk into this room and you can just feel the energy, the excitement, the momentum. Kinsey, I don't know about you, but I am so thrilled to be back here in Las Vegas, where every January we are so privileged to get a front row seat to see what's next.
Exactly. Everywhere you look, there are new ideas, creativity, breakthroughs. It's all happening at once. And Gary's right. If you are not awake yet, CES will wake you up fast.
And that's the beauty of CES. This is where we build the future. One breakthrough, one handshake, and one idea at a time.
And that future is changing fast. But before we go any further, let's take a moment to welcome everyone, especially those of you who are joining us for the first time.
Absolutely. We know the show can feel big, maybe because it is. But whether this is your first CES or your 15th, or in my case, you belong here.
What number was that?
60 or 70, I don't know, 6 or...
You did a 6-7 joke already.
This week is about discovery, connection, and stepping into the future of technology.
CES is where global business gets done. It's where partnerships and conversations turn into deals and ideas move from concept to market. For many of you, the most important meetings happen right here on the show floor, in conference rooms and in conversations that start seemingly small and lead somewhere big.
And that's why innovators show up at CES. And it's why together we solve at CES. You know, every generation has its spark. If electricity is the last century, AI will illuminate the next. In fact, as you know, Kinsey, AI is transforming every industry, every home, every life. If you think about it, fire, the wheel, the internet, every leap forward has reshaped humanity. AI is what's defining the next generation, and it's doing it faster than anything we've seen before.
That's so great. I love AI. And in fact, you know, I'm using it for all sorts of things that have helped me keep my family on track. I use it for scheduling for the weeks or even months ahead, and organizing all of my kids' after-school sports activities, and there's way, way too many of those. But we use AI to help, and it's been a real game changer for things like summer break. I also love AI in business. I like to use it because I can help analyze information faster and prepare for meetings and make better research decisions. It helps cut through complexity and focus on the core of what matters. AI is helping all of us do our jobs more effectively.
Same here. I use AI all the time to get smart quickly, especially on dense issues. I use it to compare buying options and actually think through decisions in business and in life. It's basically a research assistant that helps me cut down the time it takes to actually figure things out.
But this moment isn't just about what AI-driven technology can do. It's also about trust. People want to know, is AI empowering me, protecting me, working for me?
And people are thinking about jobs. Let's be honest here. They're thinking about their own jobs, their kids' jobs. What skills will matter in the future? What opportunities will exist?
And that's why CES matters. It's more than a trade show. It's a community and a global beacon of optimism. Here in Las Vegas is where we set the tone for where innovation is headed. This year at CES, AI is everywhere, from early disease detection and personalized medicine to robotics that bridge precision and emotional intelligence, from smarter, safer mobility to accessibility breakthroughs and creativity tools powering new entertainment and storytelling. And what stands out this year is how tangible all of this feels. For example, there's a holographic windshield display from Hyundai Mobis that turns the entire driving experience into something safer and more intuitive, keeping critical information in your line of sight. And then you also have AI Tutor, which has smart glasses from Persona AI, showing how intelligence can meet people where they are and adapt in real time to help someone learn a new skill, solve a problem, or do their job better. Or on our startup floor, Eureka Park, innovation becomes deeply personal. There's one company called Earflow, which is introducing an over-the-counter medical device used to help treat ear infections in children. I know I would have loved that when my kids were little. You probably feel the same way. It's a small device with the potential to make a big difference for families. And on an entirely different scale, Hitachi's digital asset management platform is using AI to monitor railway systems, helping keep critical infrastructure safer, more reliable, and more efficient.
Well, that's the power of CES, which this year spans about 33 FIFA World Cup soccer, or as everyone else calls it, football fields.
Wow.
Now, we know that's a lot of space, but don't worry. We really try hard to organize the show into categories that can help you navigate it in a way that maximizes your time here in Las Vegas. There's digital health and smart home at Venetian, showing how connected, intelligent living is becoming more intuitive, efficient, and personalized. You can also find one of the favorite parts of the show for me and for so many of you, the vibrant startup floor, Eureka Park in the Venetian. This show has always been designed so that anyone with an idea can expose it to thousands of people that'll make a difference in their business. Mobility is in West Hall and showcases innovation across land, sea, and air, from autonomous vehicles and advanced driver assist systems to marine technology and next-generation aviation. You'll find enterprise in North Hall and accessories, design and sourcing in South Hall, where form meets function and ideas turn into products ready for the global market.
But that's not all. Central Hall is the home for immersive entertainment and our Creator Lounge. And AI and Quantum is at our new CES Foundry in the Fontainebleau on Wednesday and Thursday. And finally, you have the future of advertising, content, and entertainment at C-Space across 3 venues, including Aria, Vidara, and Cosmo. And of course, we want to make sure you are able to visit the Innovation Showcase in the Venetian, representing the best of early-stage innovation from around the world. It's where you can see what's coming next, all in one place. And speaking of startups, the Sharks are going to be back at CES. Shark Tank will be here and holding auditions on site. We are so thrilled to welcome them back to CES. It's just more proof that CES continues to be a launch pad for bold ideas and big opportunities.
Now, we know we just threw a lot at you, but if you ever need help navigating the more than 2.6 million net square feet of exhibit space, that means exhibit space not counting aisles, the CES app is your best friend. It hands down the easiest way to navigate the show floor, find conference sessions, track exhibitors, and build your schedule. So if you have not downloaded yet, now is the time. Well, after we're all done speaking. And don't forget the in-app AI assistant. You know, I really love it. I wanted to call it Gary GPT, but that was overruled.
Wait, what? I thought we decided that it was going to be, GPT was going to be Gary's personal thinker. No?
Great idea. Let's do it.
Don't steal that from us. We're gonna do that. But in all seriousness, innovation comes to life everywhere you look. But I think it's the people you meet who make CES truly unforgettable.
Absolutely. It's all about the people. I am the paid cheerleader for the tech industry, but it's all about being with people, learning new businesses, having new ideas, serendipity, figuring out whether you can trust someone to do a business deal. That's what it's about. In fact, one of my favorite parts of CES is when someone stops me in the hallway and says, "You may not know me, but I have this amazing idea," and it's usually a pretty interesting idea. But those are the moments of serendipity which really matter. And I remember when you stumble into conversation or a demo you don't expect, and suddenly you're thinking about everything in technology in a completely different way and getting ideas about who they should meet.
And that is the magic of this show. It's not just about what's on the agenda. It's about what happens when people come together, share ideas, and make connections for things that they couldn't even plan for. I had a moment like that many, many years ago when I walked past a very small booth on the show floor and saw one of the first Fitbit devices. At that time, it looked really simple, but you could feel that it wasn't just a product. It was the beginning of something bigger. That was one of the first moments I realized health was not just a trend. It was going to become a core part of how technology improves our lives. And CES was where that future first came into focus. And speaking of people you meet beyond the show floor, CES programming brings new ways to learn, lead, and collaborate.
Absolutely. In fact, we have some awesome new keynotes spawning manufacturing, digital twins, agriculture, investment, entrepreneurship, and more. Last night on this stage, AMD CEO Dr. Lisa Su gave the most powerful vision, an incredible keynote laced with people who are making a difference in the future of the world in so many different ways. It's not just a faster chips, but it's a new era where AI drives every layer of computing. Her message was clear. AI is the tech that will define the decade.
And up next, we have Siemens CEO Dr. Roland Busch, and he will outline how AI, robotics, and digital twins are convening to make the world programmable. Then we have Havas CEO and Vivendi Chairman Yannick Bolloré. He will address the advertising and entertainment and content community at C-Space in Aria, and that's this morning at 11 a.m. He's going to share his vision for a future where technology and human ingenuity converge to unlock new creative possibilities. And at 2 p.m., I'm very excited, Bob Sternfels and Hamat Taneha, along with Jason Kalkanis, will bring us an all-in conversation with a live taping of the All In podcast.
And you have the good fortune of kicking that off.
I get to kick that one off.
She pulled rank. Tonight at 5 p.m., Lenovo CEO Yongqing Yang brings all AI all the way into the amazing sphere. Think F1 racing, immersive sports, and the first AI-powered World Cup. Tomorrow morning, Caterpillar CEO Joe Creed shows how a machinery giant is becoming a tech company, moving the earth with intelligence instead of added weight.
And across CES stages, you'll hear from leaders shaping the direction of their industries, executives, founders, and technologists whose work is defining what's next. We have Corey Berry of Best Buy, Jimena Gates of Build Within, Jensen Huang of Nvidia, Jennifer Kostar of Sphere, Samantini Godbole of Lowe's, and Nikki Santori of IMDb. These executives' work is shaping computing, manufacturing, retail, immersive entertainment, media, and the future of technology. These leaders aren't just part of the industry, they are defining it.
And we're grateful to our partners, including the Female Quotient, for their collaboration in showcasing leaders that are driving innovation across the global tech ecosystem. And Motive for sponsoring our new hands-on AI trainings. We're also actually very proud, and it's very important, to sponsor and host our first ever Women's Health Summit, bringing innovators, clinicians, investors, and policymakers together to actually spotlight technologies that are improving outcomes for women. So important. Manufacturing also has gotten on the radar screen in the last year, if you're paying attention. It takes center stage here at CES, too, with a dedicated manufacturing pavilion with our partner SME in Central Hall, highlighting how AI, automation, and digital twins are reshaping production, supply chains, and global competitiveness. You'll hear directly from leaders shaping this transformation, including Jay Timmons, President and CEO of the National Association of Manufacturers, and Janine Coons, CEO of SME. Content creators also show up in big numbers at CES, and we're thrilled to host them at our CES Creator Space in Central Hall.
This year, we are proud to introduce a new accessibility stage located in the Venetian and presented by Verizon Accessibility. The stage is a powerful reminder that the best innovation is inclusive by design.
Wow, there's just so much new at this show.
So much.
But what is it that ties all these amazing themes and activations together is people.
People. CES works best because it brings together different perspectives, experiences, and voices, creating space for all of them to be part of what's next. And today, what's next is being written in real time, powered by AI.
Kinsey, how many times do you think we're saying AI on the stage this morning?
Should we make a little drinking game out of it? Maybe it's a little too early in the morning. Well, I'll tell you, I don't think the limit exists.
I agree.
AI isn't part of the story, it is the story. But another chapter is emerging, and that's quantum.
Absolutely, and that's why we're launching the CES Foundry, bringing AI and quantum innovators together to figure out what's next.
CES Foundry is CES at its best, where the next chapter of innovation takes shape, bringing together AI, quantum leaders, startups, researchers, investors, and policymakers for real conversations, live demos, and hands-on exploration of what's coming next. At CES Foundry, you'll see breakthrough demonstrations, hear from leaders shaping the future of computing like AMD, IBM, Nvidia, and so many more.
In fact, when we talk about AI and edge leadership, one of the companies that's been pushing the boundaries for years is Qualcomm. They've been redefining what's possible as intelligence moves from the cloud to the edge. Ladies and gentlemen, a special surprise. Please join me in welcoming Qualcomm President and CEO, Cristiano Amon.
Gary,
welcome, Cristiano.
Very happy to be here.
Thank
Kinsey,
you
how
so
are you
much.
doing?
We're so happy to have you.
Thank you for coming, Cristiano. It's always great when you grace our stage. You've been so amazing as a leader, as a company. But I want to know, what are you most excited about where we're heading in technology?
Yes, look, there's so many things I think changing, especially as part of your conversation this morning with AI. And I actually going to say, even following CS to all those years, I think what's happening is also exciting for CS, and I'll explain that to you. But look, as we start creating those incredible AI models, we all want to see humans using it. And I think AI is really coming to consumers. And a company like Qualcomm that has been to the transition of the mobile industry since the beginning, we're starting to see, as you think about agents that are created with AI, is actually changing every consumer device. And we're starting to see that happening right now when we think about the evolution of mobile devices, where the things that we wear, whether it's watches and glasses, pendants and jewelry, all those things become smart, allow us to connect to agents. And we are starting to see how the whole computing and the entire consumer electronics industry is changing, because now the computers understand what we see, what we say, they understand our world. And as the AI gets produced and it goes into all of the devices where the humans are, we are actually seeing this massive transformation happening with consumer electronics. And that's the reason I made this comment, because I remember, our history with you and with CES, and we look at the consumer electronics, the mobile devices. Now CES is one of the biggest auto shows. And when consumer electronics are also coming back because they all become smarter, and they actually have now this computing capability that understand us. And I think that's incredibly exciting. We actually believe this new category of personal AI devices is going to be massive. It's going to be as big as phones, and we're just the beginning of that. So it's an exciting future.
Cristiano, we love everything you're saying, and it's so great to hear all of this. And since CES is about the future, we have to ask about the future. And can you tell us why this direction that you've just talked about is so important and where it's all headed next?
Look, as AI goes into everything, right? And it's the new, I think the way we think about a Qualcomm, it's just a new way of doing computing and software. And not only is it going to go to everything that we interact with, but it's going to things with this physical AI. And actually, that's been one of our biggest story at this CES with the emergence of robotics and all of this new industry that's created by physical AI. And I think it's incredibly exciting because not only, there's obviously this conversation about, productivity enhancements and all of the things, but exactly we see incredible potential of enhancing human ability, and the market is massive. Like we can barely quantify today, I think, how big this physical AI opportunity is going to be. I think it's one of the most exciting times for technology, and it's actually great to see all of those things coming together here at CES.
We couldn't agree more. Well, we can see all of this in action, what you've just talked about, at Qualcomm's booth, which is in West Hall, number 5001. We hope that you all will go there. Cristiano, we are so grateful for your leadership and for Qualcomm's partnership at CES for so many years.
And you've been fabulous, but I do have one more question.
Yes.
Go for it.
So most of the people here are believers in AI. But if you could clarify one thing that you wish people, average people, understood around their kitchen tables when they talk about AI, what do you think it would be?
That's a loaded question, but I will say the interesting thing, of course, we all started going to Google Gemini, ChatGPT, and you ask questions to get an answer. You change how you do search and all of that. But the interesting thing is this new way of doing computers that really understand our world the way we understand it, understand the context, is really going to completely change how we interact with them. And it's going to democratize technology dramatically. I know that's not what we're talking about today, but this whole concept that I just described, how mobile devices are going to change, this is also happening with the upcoming transition of mobile to 6G. Which is all about AI. It's all about AI. It's the network understanding the context of everything that is connected to the network to help those computers be able to do it. And I think the way I like to describe it in a simple way that people understand it, like when we think about the future of smart glasses as an example, it's like you're going to be walking in your daily life with somebody, like with a friend. And it's like if I walk in here, that's not the case because I know you, but it will, like the agent will tell me, hey, Cristiano, that's Gary. You may want to say hi, talk to him. Cristiano, you have a moment right now in your schedule. Can I talk to you? There's something we need to think about it for your meetings next week. It's going to be like that. It's going to change how we think about interaction with computers. We're just at the beginning. This is going to be a decades-long process. But agents are fundamentally change our understanding of application and programs.
Well, thank you for sharing that vision, and I want you back here next year to talk about that and 6G. We talk about that. We talked a lot about 1, 2, 3, 4, and 5. And ladies and gentlemen, let's give it up for Cristiano Amon.
Thank you. Thank you so much.
Thank you. Thank you so much. That was awesome.
Thank you.
Thank you. That was great.
Absolutely. I mean,
I'm
we're
glad you
living.
snuck that last question in.
Yeah. We're living in a time of extraordinary opportunity. And of course, there is growing risk. We know that. And around the world, policies are either accelerating innovation or they're slowing it down. I'll be the bad guy. Here's what's not working. Trade restrictions and shifting tariffs.
Government affairs, right over there.
Also, rules that limit rights or restrict the tools that people rely on. Policies that are shaped by fear instead of facts. And mandates on design instead of performance. All of this creates confusion and uncertainty and stifles innovation. And that's why we don't just sit around and say, this hurts. We've created something we call our innovation agenda. That's a clear set of priorities that we believe must be right if innovation and competition are going to thrive.
And I'm going to tell you the good news.
Of course.
Because the good news is
the lady in white.
We know what works. Around the world, we're seeing countries adopt more consistent national frameworks that protect consumers while still keeping innovation open, competitive, and human-centered. We're also seeing innovators and content creators collaborating, not litigating, to promote creativity, protect rights, and unlock new opportunities. That balance matters. Fair use matters. It's one... Thank you.
That's worth a clap.
It was Michael Petrica. It's one of the reasons creativity has flourished in the digital age and why new technologies can build on what came before.
Thank you. Absolutely correct. And in many cases, the market is doing exactly what it is supposed to do. New technologies are emerging that supercharge free expression and creativity. It gives creators more control and expands what's possible. And often it's faster than government or regulation ever could. The best role for government is to set clear, big goals and to set clear guardrails that minimize uncertainty and litigation and let innovators and consumers figure out the rest.
And that's why we celebrate our most innovative countries with our Global Innovation Scorecard, because this moment will define who leads the future and whose values guide our technologies. We need collaboration, not silos, among companies, researchers, and policymakers.
Let's take a look.
People are the reason. Behind every breakthrough is a human story of creativity, resilience, and hope. Technology is at its best when it amplifies human potential. That's what we celebrate here at CES. People creating solutions that make life better for others. We celebrate the innovators helping children learn through adaptive education tools, diagnosing diseases earlier, and communities gaining access to clean energy and connected healthcare. This is technology serving humanity.
We're back.
It's us.
Just a few more minutes of us. But moments like these remind us actually, though, why innovation matters. In fact, my own mother battled Alzheimer's for over a dozen years. And now today, seeing technologies that support cognitive health and reduce loneliness hit very close to home. For me and for millions of people around the world, it's about dignity, independence, and quality of life.
And at CES, we see technologies that make our lives healthier, safer, more efficient, and more connected. Technologies that are solving the world's biggest challenges.
And we advocate for policies that make all these great things possible.
Because AI is the spark.
And CES is the proving ground.
And people are the reason.
And on behalf of the entire staff and CTA's Executive Board, welcome to CES 2026.
Nailed it.
It is so great to kick off CES 2026 with you and to see what can happen when AI begins to animate the physical world. In a moment, you're about to experience what this looks like at a global scale, from a company uniquely positioned to embed intelligence into our real-world systems. A company that has nearly 2 centuries of experience shaping the infrastructure that powers modern life, transportation, factories, energy grids, and it's now driving the next wave of innovation through comprehensive digital twins, intelligent automation, and yes, AI. That company's Siemens. This morning, Siemens President and CEO Roland Busch will share his vision for how AI will transform the everyday for everyone. Roland is a physicist, an engineer, a strategist, and one of the world's most influential technology leaders. He understands that the success of AI won't be defined by algorithms alone, but also by infrastructure, by integration, by innovation. And his perspective aligns closely with something that Kinsey and I shared in our keynote this morning. AI is the catalyst for a once-in-a-century transformation. All across the show floor this week, you'll see AI on display, innovation everywhere. And we believe deeply that companies that can scale AI into the physical world will define the next era of human progress. And that's where Siemens stands apart. They're not just imagining the intelligent age, they're building it. Under Roland's leadership, Siemens is enabling factories to operate with fewer errors and greater output. They're bringing resilience to global supply chains, sustainability to buildings. They're driving breakthroughs everywhere from drug discovery to grid stability. And they're developing the technologies and partnerships needed to ensure that AI can actually scale reliably, responsibly, globally. And today, you will get a first look at technologies and partnerships that will shape global industry for decades to come. You'll hear stories of real-world impact, and it's a remarkable keynote from a remarkable company led by a remarkable person. Ladies and gentlemen, please join me in welcoming to the CES 2026 stage the President and CEO of Siemens, Roland Busch. Welcome to the CES stage, Roland. Have fun.
I want you to think back to the time before electricity. The world moved at the pace of people. Horses bridged our distances. Steam powered our machines. And ideas moved only as fast as a letter or a human voice. Then electricity arrived. This general-purpose technology became the foundation of modern life. It turned night into day, amplified human capabilities, boosted productivity, and powered progress that once felt out of reach. At Siemens, we brought this world to life, pioneering telecommunications and electric grids, developing the machines that accelerated mass production, moving people and goods via electric trains, scaling the benefits of electricity all around the world. Fast forward, 1.5 centuries later, another general-purpose technology has arrived. And this time, it's not about energy, it's about intelligence. Artificial intelligence will be as transformative for this century as electricity was for the last. It's redefining how we design and manufacture products, from the phones in your hands to the cars you drive. It's revolutionizing how we build and operate infrastructure, including buildings just like this one. And it's allowing us to make entire systems, grids, cities, economies, more adaptive and more efficient. A century ago, Siemens helped build the world in the light of electricity. Now, we get to do it again in the age of intelligence. We are powering the industrial AI revolution. It has already begun, and it's picking up steam faster than steam ever did. In fact, steam took 60 years to transform society. Electricity, 30, computers, 15. For AI, we're looking at 7 years or less before intelligence is embedded in the system we rely on every day. And that changes something fundamentally. Because when AI enters physical system, it stops being a feature, it becomes a force with direct real-world impact, a force that transforms how we design and build, how factories produce, how infrastructure operates, how the world powers itself. Now, how do we do it? How can we make this happen? How can we do all of this at speed and scale? And at the same time, in a way that it's reliable and safe. And hallucination is not acceptable when AI is deployed in the industrial world. Today, we are making it easy for you to scale industrial AI in the real-world systems to create real-world impact. We are bringing together AI-powered technologies, industrial domain know-how, and the right partners. And the whole thing is connected by data, valuable industrial data. And all in one place, in our Siemens Accelerator Marketplace. So let's have a look at these elements one by one, and let's start first with the right technologies. It is about software, hardware, compute, highly performant compute with GPUs, and of course, it is about data. Here comes the good news. Many companies have already some important elements in place, but this does not make them AI ready yet. Digital twins can simulate and software can solve problems, but they do not recommend what to do next in the real world. Compute is CPU-based. With AI, needs GPUs to deploy its full power and speed. And too often, data is fragmented, trapped in silos, and unused. That's why it is so important to have an end-to-end AI industrial stack to make impact in the real world. And at Siemens, we are able to build this because we have been working with AI for industry for more than 50 years. And today, Siemens has more than 1,500 AI experts, and all our engineers live in both worlds, in the digital and in the real world. And all our colleagues, over 250,000 of them, bring deep domain know-how in our 30 industrial verticals. And that's because for decades, Siemens has been helping customers in the United States and all over the world to automate manufacturing, to run railway networks, to design and operate grids, or to operate buildings more efficiently. In fact, today, in 1 out of 3 manufacturing machines worldwide runs a Siemens controller. With our software, you can build the most comprehensive digital twin of products and, of course, of a whole manufacturing site. And now we are adding AI. Decades of experience in software, hardware, and AI, and this experience means we have the domain know-how to identify which data matter and how to cluster it. Which AI applications make sense and which decisions should be left to humans. And finally, our partners. For industrial AI to make use of all of this industrial design, manufacturing, and operating data, you need huge amount of compute. Gigantic centralized AI factories that are run by our partners like AWS or Microsoft, but also at the edge, very close to your machines, to your infrastructure. With this massive GPU process-powered compute, digital twins no longer explore just thousands of options, but hundreds of thousands of them. Complex industrial foundation models can get trained on unprecedented amounts of industrial data. And a digital twin can control a whole plant in real time. When these things come together, the right technologies, industry domain know-how, and the right partners, that's when we stop just reporting issues and start anticipating them. That's when humans stop reacting to errors because machines have started to act and adjust autonomously. That's when companies can turn ideas into real-world impact with speed, quality, and efficiency. It's the industrial AI revolution. Now, I mentioned partners, the right partners, the best partners, and including a very special friend of mine, and we hit it off immediately. He has a visionary engineering mindset. He thinks through problems from first principles. He anticipates the next development step of AI technology, and he has both bold vision and the ability to make things happen. Please welcome Chen Wang.
Am I on? Would you hold this for me? Roland.
Good to have you. Good to
Happy
have
New
you.
Year. Happy New Year, everybody.
Happy New Year. Please.
200 years old. You've seen a few of these industrial revolutions,
We
actually.
did. We are not quite 200 years, but we're heading for it.
175.
Absolutely. Exactly. And we came a long way with our partnership too, right? I mean, we kicked it off a couple of years ago. I remember that very well. We have the same vision, industrial AI operating system. That's what we want to build. Huge opportunities for our customers. So what's with you? Where are we on this journey now?
Yeah, it's an incredible thing. So we did a press conference at Siemens headquarters.
In Munich.
How many years ago was that?
It was 2022.
It was only
2022.
Okay, yeah, it was 3 years ago. And we spoke about this moment, in fact. And Siemens is unquestionably at the foundation of every industry that we participate in, that the world builds on. And we had a vision that Siemens, and this was your vision, to turn Siemens into a software-defined company. In a lot of ways, described it in a way very similar to a computer company. And it would of course, have the underlying infrastructure of computing, but mostly on top, your infrastructure software, artificial intelligence, and it's going to revolutionize the way things are designed, simulated, planned, and operated. And that was the vision you described, and we spoke about 3 years ago, and here we are. Here we are at the beginning of that journey, and all the pieces are now finally coming together.
It seems to. And talking about what you achieved, I brought an example. You know that, HD Hyundai. I mean, they built ships, huge ships, and shipyards, by the way, and they use our technology.
That's right.
They're sitting on Nvidia
This is a
technology.
digital twin of an entire ship. Every nut and bolt is in there. It's incredible.
I mean,
This is the full CAD of the ship.
visited
The perfect,
millions.
precise digital twin.
And you see also the people working on the ships. You simulate everything. By the way, these ships they look alike. So the body is the same, but each one of them is individual. So you really have to be very, very clear how you design it. You optimize in the digital world, and then you build it, not
That's
before
right.
that. And that's where our whole stack comes together, complementary technology. For the photorealistic representation, we use Omniverse.
And
we
this
use
is
channel
really
of the
quite a
iStack.
perfect example of the type of work that we do together in this realization of this digital twin idea. That you would design every aspect of engineering. It's not just the CAD, but the computing, the electronics, all of it would be integrated and built into a digital twin. it would, of course, run all of the software in the digital twin. And in the future, I hope this ship, this digital twin of a ship, will actually put it in the ocean, a virtual simulation of the ocean, and see it completely operate.
Exactly.
Yeah.
And you have only one option to get it onto water. If that fails, you have a problem, by the way. So, well, we talked about bringing our partnership to the next level. And the whole idea is obviously to take these examples and scale them even faster. And of course, to make it AI enabled, I'm talking about industrial AI, which really hits the real world. And we picked 5 areas of collaboration where we want to intensify, and that is good news for our customers too, I guess. Let me start with the first one, take them now one by one. The first one is AI native chip design. So if it comes to chip design, I don't need to tell you something. Obviously, with each next generation, you're getting closer to the physical limits. So tell me what the challenges are and what can we do?
Well, let's use our latest generation that we just announced yesterday as an example.
Congratulations.
So Vera Rubin, in order to build the latest generation GPU, people think that our GPU is a chip. It is a chip. It consists of a chip. But ultimately, in order for these GPUs to scale up to process the level of AI that's necessary at the frontier, these GPUs are essentially one giant rack. And this entire rack is, in the case of Vera Rubin, 240 kilowatts. It consists of altogether 220 trillion transistors. We had to design 6 different unique chips: CPU, GPU, networking, multiple types of networking switches. One is for scale up, one is for scale out, and a smart NIC and a data processor for storage, all for AI memory, basically. All of this stuff came together. Is 220 trillion transistors, is 2 tons, and 150,000 engineering years came together to build this one system that we announced yesterday. And in order to do this perfectly at a rhythm that our company runs at, the level of chip design, system integration, thermals, electricals, all of that, in a lot of ways, our GPUs is a little bit like that HD Hyundai ship.
Yes.
And what we are hoping for, and the reason why we're partnering so closely together, is so that we could build that Vera Rubin in the future as a digital twin. The entire system as a digital twin, not just the chips, but the systems, the chips, everything together, cooling, thermals, and run the thermal simulation directly through it as it is a digital twin. And that's our vision. And so we're accelerating the first part of our project together, our partnership, is to accelerate Siemens EDA, Siemens Sim Center, accelerate everything we can with GPUs. And this way, we could scale up the simulations that we do and achieve the virtual digital twin that we hope for.
So what we're going to do is we will use Yakuda software. We will rewrite our EDA software so it can take advantage of GPUs.
That's right.
So working with GPUs and designing GPUs.
Imagine EDA software being 100 times faster.
Exactly.
Or being able to scale up 1,000,000 times more, right? That's our hope and dreams.
But we don't stop there. Still, we talk about AI native chip design. What we want to do now, we want to train our technology, our models on a massive amount of data so that it's not only about validation of design, but really making a proposal of new designs in EDA. This is breakthrough. It's never done before. That's what we're heading for.
The goal of an engineer is not to write Verilog. That's not the goal of the engineer. The goal of an engineer, of course, is to solve problems, imagine great solutions. And it would be incredible one day. There would be agentic Siemens EDA designers that are sitting with our designers.
Exactly.
And they're exploring ideas together, trying iterations and exploring boundaries.
Number 2, we talk about same thing here, AI native simulation. So when it comes to simulation, obviously this is a lot of number crunching, and it very often still runs on CPUs. This in the first step, we want to bring this technology, the heavy number crunching elements of our simulation to GPUs. That again accelerates X times, 100 times, 1,000 times. And if you can, I mean, there's an example. This is a car simulation, by the way. It goes back to when we started off our partnership from BMW. where we simulate the airflow, the aerodynamics, and it's a lot of consumption of, and it takes a lot of time. So if you speed it up 1,000 times, you can do much, much more iterations. Again, we do not stop there. We want to have simulation not only to validate, but to create.
That's right.
Again, you need a lot of data, you need our technologies, and that's where Nvidia has.
This is
also
our
a lot to
technology
do.
running in real time. Our technology together, isn't it? You know, simulations, physics is beautiful. I mean, that's just the bottom line. Numbers are beautiful.
We do that. And you do
Only
that
an
all-
engineer would say that. Numbers are just so beautiful.
And we do that for trains. And again, we're using physics Nemo from Nvidia and the full Siemens simulation stack with our
Siemens
simulation
has the world's leading suite for industrial simulations, and SimCenter and all of the suites of solvers in SimCenter. We're going to accelerate completely using CUDA and CUDA-X. We are also going to work together to create AI physics, to teach AI the laws of physics, so that it could emulate physics. Not to simulate physics from first principles, but emulate the outcome of physics, essentially guessing where the physical properties are going to go at the next second, or the next nanosecond, the next microsecond, the next second. And by doing so, we could speed up physics simulations, physics experimentations, if you will, 10,000 times, 100,000 times, and essentially create a real-life digital twin of a wind tunnel. We essentially put a real design into it, right? Real digital twin design into a digital twin of a wind tunnel and see it work. And so the opportunity to do all of these experimentation in real time is really exciting.
Which brings me, talking about physics, the real world, physical AI, which brings me to the third area where we step up, which is AI-driven adaptive manufacturing. So, this always reminds me when we talk about our technology stack, what we want to bring to the plants, which reminds me what you always say. I mean, actually, a plant is almost like a robot, isn't it? It's a big robot. So
Exactly.
or a car.
If you look at a car today, it's sensors connected to a computer. That computer is running software defined, and today the software that we run on top of it is largely AI. Well, that car is going to be made inside a factory that has sensors running computers, Siemens software stack and operating systems, and all the AIs that you'll have running on top of that. In a lot of ways, that factory, the car is an inside-out AI. The factory is an outside-in AI. And it's going to look at the cars that it's going to build, and it's going to build it robotically. So the entire factory is going to be one giant robot. It's going to orchestrate a whole bunch of robots that themselves are robotic, and they're going to make products like cars that are software defined and robots. So it's going to be robots orchestrating robots, building robots, in the future. And so this level of integration of technology has never been achieved before.
Exactly.
And so it's really the reason why we have to build the foundation of future manufacturing from the ground up. And nobody could do it better than Siemens, because you're already the operating system of manufacturing plants all over the world. And so from that baseline, we're going to, number one, make it software defined, and then two, make it AI driven. And all of that, is so great to see you drive that vision, and for Siemens to really make that possible for the world.
And we're
going to use it ourselves.
Exactly. We're going to start in Germany in 2026, a first fully AI-driven adaptive manufacturing site. We bring an AI brain on top of our software-defined automation and our operation software, which basically consumes what a digital twin produces. And here comes the beauty, we do that in real time.
That's right.
In real time, so you can really control the manufacturing side.
So our partnership, we work together and run Siemens factories. Meanwhile, we have our partner, Foxconn, working with us in the United States to run the factories for building AI supercomputers. And so this partnership is really incredible. We've talked about design, we talked about simulation, now we're talking about manufacturing, all powered by GPUs, all powered by CUDA, all powered by Siemens, and all powered by AI.
And you see in the back an example of how Foxconn is using the technology already. And again, the AI layer on top, the AI brain, with connects to the real world data and real time data makes the.
And it looks so real, but this is a digital twin.
It's a digital twin.
This looks so incredibly real, and that's really the whole purpose of the digital twin. It has to, in every physically important way and operationally important way, it has to be a perfect representation. And so, the ideal is that the digital twin and the real version of it, there is no ability for the computer to know the difference. It's to the extent that our AIs can't tell the difference between whether they're inside a digital twin or inside the physical world. That's our goal.
Exactly.
Yeah.
There are other factories too. They produce intelligence. We call it AI factories. So that's the next area of collaboration. And I know that when you talk about Vera Rubin, you need obviously new AI factories. They have to be signed differently. And you're building one on your own as we speak.
Yeah.
So we might want to share about the challenges, what needs to be different.
Well, if you take a look at the reason why I don't call it a data center is a place where people store data. These plants, in the case of a 1 gigawatt data center or 1 gigawatt AI factory, it's $50 billion. The investment level is unheard of of any type of factory ever the world's ever built. The amount of technology inside is incredible. And so if you're building something that costs $50 billion, you want to make sure there's absolutely zero scheduled delay. You're not going to be able to tolerate design changes. You're going to have to make sure that we create the digital twin, we plan it up front, we simulate everything up front. We're pushing the power, we're putting electricity, we're going to push cooling all the way to the limit. And so if we don't simulate this entire this factory in a digital twin, we have no chance of success. Yes. And then, of course, once you operate it, managing all of these computers, these AI supercomputers, the networking, the storage, and running it all at the precision we need to run it at, the control of it is incredible. So you're controlling, of course, the management of the systems, you're controlling the power, you're controlling the cooling, and this entire system is essentially one giant factory and is running all the time. And so when you put that much capital at work, you better make sure that the uptime is perfect and always, and that you're going to make sure that your scheduled delay is basically zero. And without us working together and building these together in a digital twin, the chance of success is extremely low.
Exactly.
Yeah.
We can build them faster.
This is no different. Roland, this is no different than Nvidia today. The idea that we would design chips without software is completely illogical. Exactly. Right? The idea that you would design these electronic systems without design software and verification software and simulation, come on, forget it. And so in the future, the idea that we would build plants, manufacturing plants, whether it's a car plant or a chip plant or an AI factory plant, the idea that we would build any of them without first doing it in the digital twin is completely inconceivable. And the idea that we would be able to operate these incredibly complex systems without artificial intelligence, completely inconceivable. And so I think that we know that future is here, and we know that the stakes are incredibly high, and that's the reason why our partnership with Siemens is so important to me.
We build this blueprint designs for our factories together. We have automation technology, which is much faster. It's industrial automation technology because the demand pattern of AI factories is so fluctuating. We know how to connect them to grids because we know how to operate grids. But we have
You've been doing it for 175 years.
Exactly. We do that. We know how to do that.
After 175 years, you're going to get good at something.
Well, and what we also do for more than 175 years is using our own technology.
That's right, yeah.
Which is the last area we want. I mean, actually, the people said, don't use the saying, we drink our own champagne. So now we modified it, we drink our own beer or whatever.
That's right, German company.
But we use each other technologies.
That's
we look
right.
deeper into it. What can we do more and better? And it starts, for example, with the plant in Germany I was talking about. We talk about EDA, software simulation, and bringing that to the next level to speed up our each other's development.
It's incredible. We're gonna work together to accelerate all of your EDA software, which we can then use
Exactly.
to design our chips faster so that we could accelerate your EDA software faster. We're gonna accelerate all of your SimCenter software so that we could use it to design and simulate our AI factories faster, so that we could create AIs that makes SimCenter faster. And if you look at this, and we're gonna use Siemens so that we could automate our factories to build even more amazing supercomputers, so that we could create AIs to make your AI factories even more productive.
Doesn't that sound like the perfect partnership of two companies coming together?
Yeah. And that's why whenever Roland reaches out and he needs a bug fix, I fix it right away. because I fix his bug, which directly comes back to my company, and my engineers go faster.
And I tell you, this works in both ways. So they're scared when you have a call. So, Jensen, thank you very much for the partnership.
Thank
Best
you.
is ahead of us, and looking forward
this is
to what we do.
we are at the beginning of a new industrial revolution, and what perfect company for all of that capability to come together than the company at the center of every industrial revolution. And so it's a great privilege to partner with Siemens, and it's incredible to be friends with you, and to see your vision of Siemens come together, and for our journey of reinventing industry to achieve this milestone is incredible. So thank you.
Siemens and Nvidia building the industrial operation system. Jensen, thank you. Well, when I last spoke at CES, I shared a vision of the industrial metaverse, a vision for a virtual world that helps us make the real world better. Today, we are making this vision a reality. We are excited to launch our digital twin composer. With the digital twin composer, you can create a virtual 3D model of any product, any plant, any process. Bring it to life in a photorealistic scene that you built, and in real time. The digital twin composer is so powerful because you can connect the digital twin to the real world and to real-time data. From engineering data to weather data, even time series data coming from your machines. And when something worked well or something went wrong, you can go back in time and you find out why. Or you can jump to the future to simulate designs before you build in the real world. And if you want to unlock the full benefits of the digital twin composer, you connect it to our operations software and our hardware stack. That way, you can make real-world changes from the virtual environment, optimize machine speed, temperature, pressure, or any parameter that determines the quality in the yield of your plant. This is how we combine the real and the digital worlds. This digital twin composer will be available on our Siemens Accelerator Marketplace in just a few moments. PepsiCo. PepsiCo is among the first companies to use it. And this brings me to our next guest, who is leading the way when it comes to the digitalization of PepsiCo, making the company smarter, more efficient, more sustainable with industrial AI. Please welcome Athena Kaniora.
Happy New Year. Happy New Year to everyone. It's a great year. New year, great year.
It is, it is. So, tell us about the challenge PepsiCo is navigating through, and these challenges are very much alike to what the whole food and beverage industry has.
Yeah, of course. And as Ronald said, I'm very privileged to be on stage with Roland. PepsiCo has been pioneering some of this innovation with you and Nvidia. But from farm to shelf, PepsiCo has been operating in a very extraordinary and very complex environment because we have operations Everywhere, we serve billions of consumers. We have billions of touch points per day. So consumers expect the products to be everywhere, every time, in real time, and we want to be able to fulfill the supply. So imagine a world where you have demand spikes, where you have unusual events, when you have tornadoes. You have to be able to fulfill this demand in a very digital way where the physical footprint cannot be a showstopper.
Right. So, talking about the supply chain and delivering, let's take a look at your existing warehouses.
Yeah, so, I mean, many of you know, especially the ones that come from the manufacturing world, we have great warehouses that are fully modernized, but we also have warehouses that are very old. So in this specific case, these warehouses have a century old. And that means in the current state, it really cannot serve and deliver the demand that might change depending on the events. So what is the answer? And the answer cannot be, I will just build more capacity. The answer must be, I need to find a way to maximize the capacity that I have to drive more operational efficiency and therefore increase the throughput. So what we wanted to do is adopt a digital-first design approach. And that means leverage digital twins and adopting AI at scale in all the parts of the operations, where we were able to co-design and simulate and optimize the layouts before any physical build begins.
So, and to do that, you decided to use our digital twin composer. Share your experience with us.
First of all, thank you. Thank you for the partnership. Thank you for the investment. Thank you for taking our feedback into product innovation. Today, we just had our press release.
Yes.
We are very excited to help shape this technology in partnership with Nvidia and, of course, Siemens. This is the first of its kind for the CPG industry. It's how we build AI and digital twins into our operations across the board, globally. When we say operations, that is manufacturing, warehousing, distribution centers, mixing centers, and every part of logistics. So the digital twin composer allows us to do everything in the virtual world, being able to simulate everything in a way where we don't have to spend a single dollar on the physical plant before we know the design is the final design. So therefore, we are able to pull now massive amounts of data that we are able to simulate in a unified, immersive environment. That means we can create a beautiful photorealistic way, which you saw before in the discussion. And with the AI-powered simulation now, we can explore hundreds or thousands of potential layouts to find the most efficient options. Therefore, with a digital twin, this type of task that could have normally taken months now takes days.
Well, and the question would be then, what does that do to your customers?
Yeah, well, obviously for us, making sure we serve our customers in the most efficient way, where we provide the inventory and we have the intelligent network, where both the plants and the warehouses and the network is able to anticipate the demand and fine-tune operations real time, is a must. So therefore, we have had significant impact, even in the first 3 months. So one good example is in the Gatorade plant in the US. We used the digital twin composer. We were able to drive 2 very meaningful results. One is to increase efficiency 20% just in 3 months.
Wow.
And obviously, if we were to look and we have estimated how these capabilities will benefit the company, we estimate a CapEx reduction of 10 to 15% across all the operations. So for us, this is just the beginning. We are very hopeful about what this technology can do when it comes to serving our customers, serving our consumers, and I want really to thank you for the great partnership.
Thank you for the partnership, and this is just the start. We want to see more, and we will see more.
Absolutely.
Atina, thank you very much.
Thank you so much, Roland.
Thank you.
Thank you.
You have seen the great impact the digital twin composer is having on PepsiCo's facilities. Using this technology, even in the design phase of new plants, matters, especially in the United States, because it accelerates the ramp-up of new manufacturing sites and allows our customers to make them more productive and energy efficient. But this is not just for individual
Kion, the supply chain
facilities.
solutions company.
Kion uses our technology to transform warehouses, entire supply chains too. Let's have a look.
And up and down the supply chain with AI digital twins. A new supply chain solution begins as a digital twin, compressing solutioning from years to months.
You can learn more about the Digital Twin Composer at our booth. Also on the CES show floor when you will meet the team from PAVE 360. PAVE 360. Automotive is our digital twin for autonomous driving system. And it's ready to use right off the shelf. It replicates real vehicle hardware in the digital world. Developers can simulate real-world driving conditions. They can test the autonomous system before a car even exists. And this accelerates development. PAVE 360 Automotive also replicates how the software in the car behaves. And better yet, it integrates the latest automotive IP from our partner ARM for advanced driver assistance systems, infotainment, and AI-driven cockpit features. It's a solution that will scale autonomous driving faster with the power of industrial AI. Now imagine what happens when we apply industrial AI to something more personal, even more complex, your body, your health. Life sciences. Bringing new medicines to the market costs a lot of time and money. Over the last 50 years, these costs have risen dramatically. It often takes more than 10 years, and costs are up to $2 billion. Patients and pharmaceutical companies obviously want to have faster innovations. That means tackling every step in the chain, from early research to manufacturing. And we bring AI to all these steps. Let's take the example of a new cancer drug. In research labs, scientists create billions of data points. Today, this data is scattered across industries, instruments and files, and around the world. Through our platform, Luma, scientists use AI to bring this data together and structure it. So you can ask questions in natural language. Next step, scientists identify the most promising molecular structure of the cancer drug. With AI-powered simulations, they can simulate the behavior of the molecule 2.5 million times more efficiently than ever before. And this includes how molecules move and flex, how they interact with each other, or how stable they are over time. But then you need to go from making a small batch in the lab to producing at scale without the slightest deviation in the recipe, and with exactly the same result. Even for world-class production experts, this means a lot of trial and error, a lot of experiments in a bioreactor. In our digital twin of a bioreactor, you can run these experiments in the digital world first. You simulate until you have the highest quality and the highest output. And only then you start the production. Siemens technology accelerates all steps from discovery to manufacturing. Life-saving therapies can make it to the market as much as 50% faster. And at every stage, AI speeds things up. This requires powerful AI infrastructure too. The GPUs and the AI factories I talked about with Jensen, but also the cloud infrastructure we get from partners like Microsoft. On that, let's hear from my friend Sadina Teller.
Thanks so much, Roland. It's fantastic to join all of you at CES. In the industrial sector, we have an incredible opportunity to bring together digital intelligence with physical operations to reinvent things that are designed, built, and run in this era of AI. And we're already seeing the industrial AI drive better outcomes in both productivity as well as in safety. That's why our partnership with Siemens is so important to us at Microsoft. By combining your deep domain expertise with our trusted cloud and AI capabilities, we are helping our customers tackle some of today's most pressing challenges, from sustainable energy and transportation to smart cities and precision medicine. I'm especially excited about the co-engineering work our teams are driving to build custom models and agents that get trained with real-world industrial data. And of course, we're just getting started. I could not be more optimistic about what we do together and achieve together. Thank you all so very much.
Thank you, Satya. So, custom models, agents, and of course, co-pilots. Let's talk more about it with Jay Parikh. Hi, seeing you. So, Jay, you are leading Microsoft's core AI team. You put all AI experts together, which tells me, again, this is a foundational technology which scales across the whole company. So where are you in the step of really making this AI journey, creating impact at your customers?
Yeah, well, first of all, thank you for the partnership. Excited about what we're working on today and also going forward. So as what we're seeing today is really 3 waves with more waves coming in terms of AI. The first wave was really folks using AI as a chatbot, right? To ask it simple questions, maybe do code completions. The second wave is much more focused on delegating a specific task to AI, maybe giving it a task to do and come up with a market strategy document or proposal to do these longer running, kind of more sophisticated tasks. Now, what we're seeing emerging in this third wave is this set of agents working with and orchestrating a set of different agents to be able to do asynchronous work, but much more complicated work, right? Longer running tasks. And it is this third wave that we're focused on building because you need multiple models. You need to be able to train your own models, right? You need to be able to bring in your enterprise data. You need to be able to orchestrate these agents, but you also need to do it with security, with observability, with compliance, with all of that scale enterprise ready abstractions, right? And it is this area in this third wave that I'm most excited for us to be working together, because this third wave is how we bring this technology to specific use cases and industries. But Roland, I'm really curious, is like this third wave, how does this show up as you lead industrials with AI? How is this manifesting with your customers?
And I mean, there are many examples. I brought one. This is a very exciting one. We talk about Rolls-Royce. They do turbines for airplanes. And I mean, obviously, you want to have these turbines to work 100% reliable and, of course, fuel efficient. And within these turbines, you have a lot of design parts coming. These are designed with Siemens software and technology from Microsoft. And there's a particular one, which is a hydraulic pump. And that makes this machine turning. So this pump has now a digital twin of the pump itself, but it also has a digital twin of the machines machining it. And we simulate the whole process in programming it. And we use your technologies together with ours and simulate it with amazing outcomes. These pumps are much stiffer and lighter. But we use Microsoft as well here and AI technologies.
Yeah, and excited about the other things that we're working on with these joint AI co-pilots, right? We're able to help reduce the programming time for CAM by 80%, drove up productivity in the factory by 30%. And then also excited to work with your team to bring the GitHub platform to all of the developers to drive that innovation, that value for your customers faster. Again, all built together on Microsoft's cloud and AI.
Exactly. And there are many more examples. The demand is huge. And the benefits of not only shortening the development time, but also the production time is amazing. We talked about technology, but we cannot stop there. And we know that you're very passionate about also the other part, the cultural, the way how you transform your team, the people.
It's hard.
It's hard. I know that. So let's talk about it.
Yeah. So, you know, I spent probably last year talking to about 200 or 300 customers. And it was fascinating because somewhere between probably 70 and 80% of my conversations with customers started or ended or was dominated by this topic of change, about culture, about people, about organizations. And it was such an interesting set of conversations. And my kind of three current takeaways from those conversations were, one is like we're all learning together and we're sharing openly about what's happening in organizations, small startups to companies that are much, much, much bigger, multinational. So this culture of change is something that we have to share openly and work together on. The second thing that I noticed and comes up in conversations is actually many of the employees, many of the workers are using this technology in their personal lives, right? They're using it, they're actually really sophisticated with it for family, for personal growth, et cetera. But there are institutional headwinds to adopting it, using it inside the company, whether it be compliance, whether it be risk, whether it be security, whether it be finance, whether it be just misaligned incentives, right? And then, so it is our job to try to work and try to unlock this value, this creativity, this collaboration. And then the third thing that I always encourage folks to do is really the potential intelligence of these models, the capabilities of the platforms that we're building here at Microsoft are so much more capable than what we realize today. So my biggest encouragement to myself, to my teams, to our partners is to really raise our level of ambition of what we can do with AI to drive the world forward and to deliver more impact.
And I tell you, I can say it from my perspective, we see a lot of these changes also in working with you, working with our customers, but also with you. You come from a different environment, but we bring that together to our customers and they do appreciate it, I tell you. Thank you very much for doing that. And this is just the start.
Yes, thank you. Thank you for the partnership.
Jay, thank you. So, more powerful industrial co-pilots and now new co-pilots. Today at CES, we are launching 9 additional AI-powered Siemens industrial co-pilots. They bring intelligence along the entire industrial value chain, transforming how we design, engineer, and operate. And, well, to help everyone access this kind of technology more easily, we are now putting it in the hands of our shop floor colleagues, or to be more precise, on their faces. Together with Meta, we're making Ray-Ban Meta glasses for industrial AI. Actually, we do not use the tainted ones, as you can imagine, maybe if the sun is shining, but they're also natural ones. And they tell our colleagues to get real-time audio guidance through the glasses, which button to press, which parameters to change. Let's take a look at one of our factories when these glasses will turn colleagues into connected experts, so they can have more impact in the real world, hands-free.
Hi, I'm Sarah. I just started working at this factory. Honestly, there's a ton to learn. It's great having AI from Siemens to help me get familiar with everything.
Good morning, Sarah. Let's take a quick look at how the last shift went and what's coming up. Today, you'll be operating the robotic assembly line. I've noticed an issue with some sensors at cell 4 that could lead to assembly faults later. A reset now can prevent that. Should I guide you through the process?
What I love about my AI is how easy it is to use. It brings together live machine data, knowledge from my colleagues, and all of our standard operating procedures, then explains everything in a way that makes sense to me. At my pace, in my language.
And now select Restart.
With AI from Siemens, I can solve problems efficiently, quickly, confidently.
The first tests show that colleagues are more confident in their work and they're also more productive. That's impact in the real world by scaling industrial AI. But we're heading for another huge bottleneck. Power, electric power. AI factories and data centers require gigawatts of electric power. Now, what if? What if we had an energy source that was clean, safe, affordable, and practically limitless? That's the promise of fusion power, which brings me to my next guest. Commonwealth Fusion Systems is working on the world's first commercially viable machine to make fusion real. Please welcome Bob Mungard.
Hello.
Hi, Bob. So, for the starters, what is fusion?
Yeah, it's a good question. So fusion is the power of the universe. It's the power of the stars. And what we want to do is build machines here on Earth that create that power, that harness it. And that would mean that we would go from an energy system that is about natural resource consumption to an energy system that's about technology. Can you build these machines? How fast can you build them? How well do they run? And we work on a type of machine called a tokamak, basically a bottle that holds a star inside of it.
So these are massive machines, and there are, for decades, researchers, engineers trying to make it. So tell us, why should it work now?
Right, so we're at CES, where many of the technologies we see, were ideas even just 5 years ago. But the technical stack that has been developed from simulation tools, from the physical understanding, has enabled a lot of these technologies. And fusion's no different. We have very large simulations where we understand the underlying physics of the process. We can layer that into manufacturing these machines that are complex, but that perform these very delicate procedures. And we can build all that up into a plant that makes energy. That whole stack is enabling this entire industry.
So let's go a little bit deeper into these challenges, because, putting a complex machine together is obviously very complicated, but you also have to produce it at the same time. So you have to design and manufacture, and that's what you do also with the software from Siemens. So
that's right. This in fusion, we're developing an entire new industry. You can't just go and buy a fusion plant or a fusion part. We actually have to take it from the first principles of how do these magnets work? How do you manufacture them in a factory that can take new designs really quickly, that can iterate really quickly, that can compare test results to simulation tools and see where there's a mismatch, what we don't understand. And this produces a huge amount of data. It produces a huge amount of insight. And how do you harness that? And that's where we use Siemens technology, from the design of the actual parts to how the factory runs to how the plant itself is controlling very large amounts of current and cooling to hold this star inside of it.
Right. Actually, I was walking one of your plants where you built Spark, which is your first demonstrator where you really create more energy you put in, which is make a viability check of your technology. And it's amazing what you do. And imagine that the next one is even 2 times bigger. It's hard to believe. So tell me a little bit more about how Siemens technology played in that, designing it and, of course, in supporting the manufacturing as well.
Right. So we're building a plant in Massachusetts that is a machine that will make more power out from fusion than it takes to heat it up. And to do that, Siemens was there from the beginning of how do we actually do the design work. They're there in the factory with the PLCs that automate the factory. And this is a factory that has engineers standing right next to the equipment that's running, that's being reconfigured all the time. And then in the actual Spark facility, the brains that are actually running all the different processes, it has to all come together to make the right conditions of a star inside of it. Those machines are Siemens machines, and they're running software that has been checked out in large computer simulations accelerated by Nvidia, computation and DeepMind. It's a very big stack all the way from idea to a plant.
So now, here comes the key question. When we will see real-world impact? When will that commercially be viable?
So
available?
It's a great question. It's a question I always get. And the key part is that you can start to see things today. So we have the plant in Massachusetts, factory running, but the Spark facility is being put together. And in fact, at CES, we have pieces of it that we've brought. There's the Siemens booth. Go check them out. But we also announced yesterday that we've put the first big magnet into place for Spark. So you can see it coming together. That's setting up for the next machine, which is going to be in Virginia. That's what we call ARC. And that's a commercial machine that will make about 400 megawatts of fusion power, electricity. That can power a data center. And in fact, Google has agreed to buy the power from ARC. That is getting started here soon. And so we can see out here on this technical stack, going from science all the way to energy, we can see a new age of abundance.
So, Bob, thank you very much. There are a lot of customers counting on you to make that work, and we are here to support. Thanks for the partnership.
Thank you.
Thank you. Well, but even if we have abundant clean energy, there's another huge bottleneck: grid availability and grid stability. Today, many electricity grids are on the verge of collapse. Intermittent energy sources like solar, wind are increasing the stress on our grids. We need to predict loads better and stabilize the grid, and that in real time. Our industrial AI-enabled technologies can do this, even for huge grids and autonomously. We can simulate the impact of adding 10,000 electric vehicles to the neighborhood. Buildings all over the city can act together and coordinate energy consumption, so they could turn down their air condition for just half a minute to help stabilizing the grid. And already today, we are using AI to maximize existing grid capacity by 20% without new infrastructure. This is industrial AI creating impact in the real world. So what does this all mean for you? No matter whether you design, engineer, or operate, or all of the three, no matter what you make, food, cars, medicine, energy, no matter what type of infrastructure you manage, the water supply, a transportation system, or a grid, we have the technology, the domain know-how, and the partners to help you do what you do, but faster, more efficiently, and more sustainably by scaling industrial AI in the real world. Electricity. Today, those of us in this room barely think about it. Our lights turn on, our coffee machines run, our computers charge. Electricity is a fact of life. Soon, industrial AI will become a fact of life. We will produce only what's needed, exactly what's needed, where it's needed. Equipment failures and outages will be rare, unpredicted ones even rarer. Medicine tailored to your unique biology will just be standard healthcare. Autonomous vehicles will move with 100% reliability and zero emissions. And knowledge will transfer through generations as naturally as current through a wire. Energy will flow cleanly, abundantly to infrastructure that repairs and optimizes itself and serves a world so defined by AI that we hardly notice it anymore. When a breakthrough innovation becomes a real-world essential and a general-purpose technology becomes the invisible fabric of our lives, that's when we'll know that we have scaled AI in the real world and realized its potentials. And together with our customers, with our partners, with you, transformed the everyday for everyone. Thank you.